Relatively prime is not about one number, it's always about two numbers or more. Okay? And they don't have to be primes. None of them have to. It's the way the relationship is with each other that we're talking about. Yes?
So this is another way of finding the greatest common factor.
This is another way of finding the greatest common factor. Yes. Now, what I'd like to show you is an application of this that extends it way beyond the blocks. Maybe to illustrate it, we'll do this. Let's try this. 24 and 2. Do it with the blocks. 24 and 2. You know what the answer is, I hope. But do it with the blocks. I just need you to do this to show you there's a faster way of doing this.
Because we would have to say this all the way down to 2 is what it's saying.
No, you shut it off and then you realize there are 2.
Well, for the kids, if you would have them do this, they would have to take this.
Because you only snap it off until, yeah, they keep going down.
What did you get?
And they keep, yeah,
But it was
you know,
rather tedious, right?
Yeah.
Because you just kept repeating what? Breaking 2 off the bottom and throwing it away? All right, watch. This is not with blocks, but it's the same Euclidean algorithm. Take the two numbers, divide the small one into the big one. 12 goes into 20 one time with a remainder of 8. Is the remainder 0? No. So I keep going. Watch. I take the remainder and divide it into the old divisor. Take 8, divide it into 12. How many times will 8 go in there? Once. Remainder of 4. Do I have a remainder of 0? No. Then I keep going. Take the remainder, divide it into the old divisor. 4 goes into 8 twice with a remainder of 0. Do I have a remainder of 0?
Yeah.
You're always asking that question. As soon as you get a remainder of 0, you stop. Where do you find your answer?
The divide.
The one.
Actually, it can be found in a couple of places. It can be the last non-zero remainder or the last divisor. That is my GCD. And basically what that is it kind of cuts to the quick here. 2 goes into 24 12 times with a remainder of 0. So it is my last divisor, 2. That's faster than snapping off 2, throwing it away off the bottom, snapping off 2 off the bottom and throwing it until you keep getting that down. Because we're going to learn in Unit 4 that subtraction is what you're doing, snapping them off, and repeated subtraction is just division, right? So this idea of dividing can speed that up. You're after a 0 remainder, and you look at either the divisor of that problem or the remainder from the previous problem, which is where that came from. You're going to need that tonight. Would you please make sure your sacks are the way they are when I got them and stack them